Current of electricity and direct current circuits. This video will cover sections 13.1 to 13.5. 13.1 shows some practical circuits and the symbols of various components. So you have to memorize all these circuit elements such as ammeter, voltmeter, etc. Electric current is the rate of flow of electric charge. The formula for instantaneous current is dq dt, I equal to dq dt. Average current will be q over t. The units of charge is coulomb, and 1 coulomb is 1 ampere second. By convention, the direction of electric current is chosen to be in the same direction as the flow of positive charges. Drift velocity. Drift velocity is something new. You have not learned it in secondary school. So the flow of electrons is erratic, but on average, they drift in one direction with a mean or average velocity called the drift velocity. So the relationship between current and drift velocity is given by this equation. I is equal to N A V Q, where N is the number of charge carriers per unit volume, A is the cross-sectional area, V is the drift velocity, and Q is the charge per unit charge carrier. Okay, example 1. The current due to the flow of positive charges, I, is given by the number of positive charge carrier multiplied by the charge per charge carrier. So we get 4.992 times 10 to the power minus 4 ampere. The current due to a flow of negative charge is similarly the number of charge carrier and the charge per charge carrier. So the net current will be the sum of these two. Here in example 2, the electrons move around the nucleus. So the current will be number of charge divided by the time taken to go one round. So the 2 electrons will pass through one single position when the electron go one full cycle. Potential difference and electromotive force. So this is a definition of electromotive force. The electromotive force E is the energy converted per unit electric charge to electric energy in driving charge around a complete circuit. In similar fashion, the potential difference between 2 points in a circuit is defined as the energy converted per unit electric charge from electrical energy to other forms of energy when charge move between the 2 points. The other form of energy can be light, can be heat. So basically, EMF is a measure of the energy converted from other forms of energy to electrical energy. It is a source that can transfer per coulomb of charge when it's driven through the circuit. The potential difference is a measure of the energy per coulomb dissipated when 1 coulomb passes through part of the circuit between 2 points. So regarding the equation W equal to Q times V, we can start with work done equal to force times distance, and the force is Q times E, where E is the electric field, and E is equal to potential gradient, which is V divided by D. So therefore, the work done will be Q times V. The formula for electric power is P equal to I times V. Alternative units of electrical energy. So in H2 physics, you have to be familiar with the kilowatt hour as well as the electron volt. Resistance and resistivity. The resistance of a device is the ratio of the potential difference across the device to the current I flowing through it. So let's take a look. Okay, let's discuss the difference between ratio and gradient. Look at the graph, there are 3 points. So the ratio of I to V for the middle point, 3.0, 2.0 is 0.67. Now the gradient is 1. So since the resistance is the ratio of V to I, the resistance at this point, the middle point, is 0.66 ohm. So that's the meaning of ratio. The resistance is not calculated using gradient. Okay, Ohm's law is something that you have seen in secondary school, and we have V equal to IR. The resistance of a wire is proportional to its length and inversely proportional to its cross-sectional area. So the constant of proportionality is called the resistivity. Resistivity is a property of a material. So for example, for silver, the resistivity is 1.6 times 10 to the power minus 8 coulomb meter. And for iron is 10.1 times 10 to the power minus 8 ohm meter. So example 3, we are to find the resistance through the surfaces PP, QQ, and RR. So using the equation, resistance equal to rho multiplied by length divided by cross-sectional area, we are able to get the resistance. So we can measure the resistance of a wire by measuring the ratio of the potential difference to current. The potential difference is measured using a voltmeter and the current is measured using an ammeter. Effective resistance for combination of resistors. For resistors in series, it is just a sum of all the resistance. For resistors connected in parallel, the equation is 1 over equivalent resistance equal to 1 over R1 plus 1 over R2 plus the rest, etc. Okay, example 4, we are to calculate the effective resistance between points X and Y. So this is a combination of series and parallel connections. So first, we find the effective resistance in the smaller loop, and then after that, we look at the effective resistance between X and Y. Okay, example 5, we are to calculate the resistance between points Q. We are to calculate the resistance between points P and Q. By identifying equipotential points in the circuit, we can see that there are 2 points Q and 2 points P. The 1 ohm resistor is between P and Q. The 2 ohm resistor is also between P and Q. The 3 ohm resistor is also between P and Q. We can redraw the circuit as follows, and it becomes clear that this is a parallel connection. Power dissipated in resistors is given by power equal to I times V, or equal to I square R, or equal to V square divided by R. So for example 6, we are to calculate the current flowing through the power line, the voltage drop caused by the power line, and the percentage loss of power in transmission. First, consider the power station. So the current will be P over V, which is 3,788 amperes. So this is the same current that flows through the power line. Hence, the voltage drop due to resistance of the power line can be found. From there, we can calculate the power loss, which is I square R. Hence, we are able to find the percentage power loss in transmission, which give us 11.5%. Okay, this is the end of section 13.1 to 13.5.